problem number 4, the baseball problem. All right, a batter hits the ball at 40 meters per second at an angle of 30 degrees to the horizontal. Again, break it down using SOHCAHTOA. This is hypotenuse sine theta. This is hypotenuse cosine theta. And whatever you do, please do me the favor and get rid of the vector that's not on the x and y axis. Again, the motion of the ball is 20 meters per second in the y direction and 34.6 meters per second in the x direction. And don't think of it any other way. They say, how far did the ball go? Let's see, it says exactly. A ball is struck at 30 degrees. How fast and in what direction did an outfielder who's staying 120 meters away run? So the guy's 120 meters away. I want to know how far the ball went, so I can tell you how far the outfielder had to run. So distance is equal to velocity times time. We want to know how far in the x direction the person had to run. So do we know the velocity? Yes, 34.6. Do we know the time it took? No, we don't. So like all the other problems, let's find out what the time was. Time is equal to velocity final minus velocity initial over A. This only works for where the ball hits the top. We can say the velocity final in the y direction is equal to 0 meters per second at that point. So we're only analyzing half the time. So we come up with 2.04 seconds, but to analyze it for the full time, we have to multiply it by 2, and we have the full time to be 4.08 seconds. That's how long the ball was in the air. I can plug this back down into the time component right there. Now we know this, not a question mark anymore, we can check that off. We put that number right here, and we have the ball is in the air, the ball was hit 141.2 meters. So what does that look like? Here's where our outfielder was standing. The ball is hit 141.2 meters. How far does the outfielder have to run? The outfielder has to run this amount, which is 21.2 meters. That's the distance the person has to run. So if he has to run 21.2 meters and he has 4 seconds to do it, again, the ball is hit, the outfielder can start running because he knows where the ball is going to go just from the sound of it coming out of the bat. He has 4 seconds to react. So velocity, the outfielder's velocity is equal to distance over time. The distance is 21.2 meters, and the time is 4.08 seconds. So he has to run at 5.2 meters per second. That's how fast the baseball player has to run to catch the ball, and he has to be running away from the batter. And I think your answer sheet says 5.24 meters per second. Again, it all has to do with rounding, so don't worry about 5.2, 5.24. That's problem number 4.